we can say it is the uniform circular motion. Okay, try to see. Suppose this is a circle and an object is moving on this circle. If it is moving with the uniform speed, uniform circular means uniform speed. Uniform speed. Speed should be uniform, means no change in speed. Let's say if an object is moving on this track with 10 meter per second, here also it is moving with the 10 meter per second. Here also it is moving with the speed of 10 meter per second. Means everywhere it is moving with the same magnitude. It means such motions are known as uniform circular motion. In case of uniform circular motion, object is moving on the circle, so its magnitude is magnitude of velocity. Magnitude of velocity remain constant. Remain constant, but direction is not constant. Direction is continuously changing, but change in direction. So, but change in direction, so we can say speed is uniform, speed is constant, but velocity is not constant. Okay. So in case of uniform circular motion, speed is constant. The speed, if I'm talking about only the uniform circular motion, then we can say speed must be constant, but velocity can't be constant because of change in direction. Okay. Let's say what is happening here. Just I'm taking a circle, and in case of just I'm recalling the previous topics, what we have studied, that is very important because we must have to keep the things in mind to bring the next topic. In uniform circular motion, theta, that is the angle formed at the center, is called angular displacement. Angular displacement, and the rate of change of angular displacement means d theta upon dt, that is marked by omega, and omega is called angular velocity. Angular velocity. This angular velocity is related to linear velocity also, v equal to r omega. If we take it in vector form, then we can write r cross f, that is equal to v. V is the linear velocity and r is the radius and omega is the angular velocity. In this way, we can correlate the angular velocity and linear velocity. Similarly, if we differentiate omega, we will get acceleration. Here acceleration is marked by alpha, since it is the angular acceleration. So alpha can be written as d omega upon dt. And d omega upon dt can also be written as d squared theta upon dt square. I hope it is clear to all because we know all these things we have already discussed in the class. Okay. And here also we can correlate alpha with A. Okay. Since we, by using this formula v equal to r omega, we can calculate alpha equal to. Okay. Now today's topic is not this. Today we are going to discuss the acceleration in circular motion. Uniform circular motion means magnitude of acceleration in uniform circular motion. Let's see what is happening in the circular motion. I'm just taking a circle. It is a circle. I'm just reducing the size of circle. Let's say it is a circle and an object is moving on this circular track. Let's say this is the initial position of the particle A. I'm just marking the radius of the circle. This is the radius, and this point O is the origin of this center. I have taken this origin as the center, and I have drawn axis which is passing through the center of the circle. Let's say this is the x-axis and this one is the y-axis. Simply I have taken x-axis and y-axis. It is the x and it is the y. An object starts from this point A. See the things very clearly. It is very important. Even it is a derivation, and so many times it is asked in the exams, and the derived formula what we are going to derive, that is also very important. You can't deal the circular motion without that concept. It is a uniform circular motion. You must keep the things in mind. Okay, uniform circular motion. Uniform circular motion. I'm not talking about the change in the magnitude of speed. I'm always taking the magnitude of the speed constant. Let's say it starts from point A and comes here at this point B in time t, at t. At t equal to 0, it is here at A. Now let's draw the position vector for B, where it is. This is the position vector at time t. Okay, object is moving on this track here, on this. At t equal to 0, it is at A. At t equal to t means after some time, after an interval of time, the object is at B. Let's say this position vector, which is at time t, is r. R is the position vector of the object which is moving on the circle. R is the position vector. Position vector. So how can we represent R in terms of components, means I and J? Listen the things very carefully. See, if object is here, this radius is r, and it is moving with the uniform speed, and let's say that the speed is omega. This is the uniform angular speed. Uniform angular speed with which the object is moving on the circular track. I hope the situation is clear. A very simple situation we have taken. An object is moving on a circular track of radius r with an angular speed omega. Okay. In time t, if we want, since the speed is uniform, so in time t, the angle formed at the center, that is theta, and theta will be equal to omega into t. Tell me whether it is clear or not. I'm just repeating. Object starts from A, reaches to B with a uniform angular speed omega. Then omega into t is the angle formed at the center in time t. If it is clear, just tell me.
तो रिपीट करना सर एक बार.
Good. देखिए, suppose कीजिए कि an object is moving on a circular track with 30 meter, 30 degree per second, 30 degree per second. For an instant, just I'm taking an example, okay? 30 degree per second, then what was the value of theta in 2 seconds, it will be 60 degree. Means object comes here by making an angle of 60 degree here. What is the value in 3 seconds? In 3 seconds, it will be 90 degree. Means object comes here. Is it clear with it?
Yes, sir.
Good. If the object is moving with the angular speed omega, omega means angle formed at the center per second. Angle formed at the center per second. Means in 1 second, the angle formed at the center is omega. Then in time t, the angle formed at the center will be omega into t. Is it clear? Tell me whether it is clear or not.
Clear, sir.
Payal, tell me whether it is clear or not.
Yes, sir.
Good. Now, just find the coordinate of B, point B. See, how can we find the coordinate? If we draw a line here, this line, this will be perpendicular. And if it is R, this line is R, hypotenuse is R, then this will be R cos omega t. This line, base line is R cos omega t. And similarly, we can say perpendicular will be R sine theta, sine omega t. Here, angle is omega t, so I am writing sine omega t. Please make me clear. Confirm me whether you have got this point or not.
Clear, sir.
Good. Then this is the x coordinate and this is the y coordinate. Means coordinate of this point can be written as first I am writing x coordinate r cos omega t, coordinate of point B, and r sine omega t. If anyone has doubt, please ask or tell me to repeat. Coordinate of point P, where the object is at time t, means coordinate of the position where the object is at time t. Confirm me. Priyanshu, are you here? Okay, so R can be written as, position vector R can be written as R cos omega t. Yes, बेटे.
सर जो आपने एक कोऑर्डिनेट बताया सर बी के सर, ये तो सर इसके कंपोनेंट हो गए ना सर, इस साइड के सर, ये कोऑर्डिनेट कैसे होंगे?
अच्छा, जो बेटा कंपोनेंट होता है वही तो कोऑर्डिनेट होता है. ये आपने क्या निकाला है? What is this? This is the length along the x-axis, okay, beta?
Yes.
And this is the length along y-axis. So the lengths which we got along the x-axis and y-axis, that is the coordinate.
सर ये कंपोनेंट तो सर इसके पूरा होगा ना सर, जो एक्स एक्सिस का होगा सर, ये तो सर इसकी पूरी लेंथ होगी ना सर इसकी.
हाँ, पूरी कौन सी लेंथ बेटा? पूरी लेंथ यहाँ तक, ए तक या यहाँ तक?
सर ये कंप्लीट लेंथ होनी चाहिए सर पूरे एक्सिस की सर, जो आर cos ओमेगा टी आई हमारी.
हाँ हाँ, that's
तो सर कोऑर्डिनेट थोड़ी लेंगे सर इसको हम.
बेटे चलो हम एक छोटा सा एग्जांपल लेके इसको फिर से समझते हैं. देखो, just take an example here. Okay, let's say the coordinate of this point, I'm just taking a point here, and this point is of coordinate 3 and 4. It is 3 and 4. Okay, is it okay with it?
Yes sir.
And let's say this is a vector for this point, position vector for this point. Mark it as R. Okay, how can you write this vector R? how can you write this vector r? Component along this is this.
Yes, sir.